Welcome again to Stats One. This is Bill Foote, and this is Lecture 10. I'm labeling it 5 Easy Pieces, not to be confused with the movie from the early 70s with certain people in it. Oh, I think Jack Nicholson had something to do with he wanted some toast, couldn't get it, and by subtraction from a standard breakfast finally ended up with this toast. Great fun, but it's really a tale of Quar. Okay, and Quar is the brown fiber from desiccated, dried out coconut husks. And it is especially useful in manufacturing activated carbon. Activated carbon, in turn, has properties, one of which allows it to be an excellent filtration substance. The material, carbon itself, can attach to particles sometimes as small as 5 microns, which is close to virus level. And thus it is a popular filtration component in things such as, oh, where is it over here? A surgical mask. Many of us are pretty familiar with that, but it is also for water and chemical and other types of filtration systems. It's used to, for example, polish water into certain properties useful for various industrial processes in the food industry and in the power industry, for example. We're still going to pose, form, sample, count, and infer. And we need to keep that in mind. But the way we count things and infer things, we're going to have 5 different approaches. We've already used one extensively. It's a simulation approach with a grid where we create a distribution, a plausibility index, if you will, that shows just how our hypotheses, what we're forming, which of course are based upon a question or so that we're asking, are compatible with, consistent with, plausible with a sample of actual data. And the counting method we use is something we learned from day one. So that'll be the basis of what we're doing. But we also learned how to use John Tukey's exploratory data analysis. That was one of the first ways with interquartile ranges. Again, that's a percentile approach. The percentile approach can be expanded from John Tukey's approach to getting at the percentiles, the quantiles, as we usually call these in statistics, the quantiles at the 5, 10, 15, so on, up to the 95th and 100th percentile. Now, these are cumulative, not just relative percentiles. And it's very important to realize that each of these methods, including the interquartile range method for Tukey's fences, is a cumulative relative frequency, a cumulative density function, if you will. So the question we're going to pose here is a question asked by procurement officers in companies that make activated carbon or use activated carbon in their industrial processes. For example, to make mask filtration systems for healthcare and anybody who is involved in a high particulate environment. Well, they have to make a contract, don't they? So they will have to know some idea of what market prices will bring to that contract, what people will negotiate with. And in the absence of knowing anything at all, you go out and you have a request for bid, a request for quote, an RFQ. And you will send that out to various vendors, probably brokers, but usually direct dealers and vendors, people, companies, situations, governments even, that have an inventory of this primary material used to make activated carbon. So the question we're going to ask is, what's a high price? What's a low price? Now, real high prices probably mean price gouging. Real low prices, we might be skeptical and wary about the quality of the underlying commodity. It might have gotten wet and damp and might not be very efficient in our production process, for example. Price gouging will speak for itself. Paying a very high price and an existing transformation process, the value at the end of that, the value added might actually not, it's always there, but nobody will want to pay for that value. The price, there's always this issue between price and value. They're not always the same. So we'll form some hypotheses about this. And those hypotheses will involve means and standard deviations again. But they could also involve mean absolute deviations. They could also involve skewness and kurtosis, all of which are going to be important properties of markets. They're the facts of these markets. And the facts of these markets are, we don't know where these prices are going. Now let's just look at that for a moment. Just turn the page here and look at prices from the international coconut community, which is an industry group mainly in the southern hemisphere, out of Sri Lanka, India, Indonesia, which are the primary, and the Philippines as well. And you can see those notes there about these weekly price updates that are across the spectrum of products. There's a wide variety of products. We're going to be looking mainly at coconut fiber. You see, we only have a Indonesian price of $250 per metric ton. These are metric tons. These are more than the US 2,000 pound tons. I think they're closer around 2,200 pounds, as I recall. You can see some of these countries lining up here. There's some graphics here, but there's a publication. Let's see if we can get some market review here. And we can get a weekly market review. And let's choose 2021. Desiccated coconut fiber. See if there's anything else. Let's try desiccated coconut for the moment. And look at a market review in February of 2021. And we can see that desiccated coconut, which has gone through a process, can have a high, for example, of 3,500 and a low, just looking at this particular one, Sri Lanka, and a low of approximately 1,500. So this is already partly processed, an example of that. We go back to the market review. Let's pick a different one. Let's pick coconut fiber. And let's get the March one, which is roughly the same time. And there is core fiber. Now this used to have a graph associated with it. They seem to have gotten rid of it. Notice where the major destinations are for coir product from Indonesia. Coir is the commodity name for fiber. Various molded products and so on. Sri Lanka has a declining trend. Here's a price that's going down as low as $107 per metric ton. Okay. Indonesia has a high of roughly 302,000 per metric ton. So we can get some ideas from these market reviews to help us understand what is going on. Let me pull up a November one, see if we can get a picture. Yeah, there's some tonnage movements here. You can see where the volumes are exported and the types of products in various destinations for horticulture, for example. And this is what we're looking for. There's a monthly price of corn. And in this monthly price, January 13 to September 21 last year, you see a high of roughly 400 or so for Indonesia at the top, and a low of around 250, 260. And you see a high of a little over 250, maybe 250, 260 for Sri Lanka, and a low around 100, much what the reports were saying. The difference between these two usually represents the basis between two physical locations. If you send it out from, if you were to exchange between Indonesia and Sri Lanka, this would otherwise be the cost, insurance, freight. The difference would be insurance and freight. Typical physical basis. How much does it cost to transport? The value is higher in Indonesia than it is in Sri Lanka. Probably not because of the cost of production itself, the harvesting, the storage, even the insurance at that end, from plantation to quay and wharf. But if you were to send, suppose one of the main outlets for Indonesia is China, they would be buying it at that magenta price. But if they needed more than what they had at Indonesia, you might go to Sri Lanka, get a cheaper price, but the differential would be how much it would cost for insurance and freight. Okay? So we need to take these things into consideration when we start thinking about what we're doing with these products and so on. So that's all going to be part of what we have to think about. We're going to use a sampling technique like we already have with sales revenue. We're going to use a sampling technique that will take the place of making 12,000, no, sorry, not 12,000, 10,000 phone calls to 12 different vendors. All right, so this is a thought experiment, and it's the use of simulation once again. We're going to use RAND between. We're going to use a number of things to help us with sampling and resampling, and that is called bootstrapping. Okay, so let's turn to a model that we can build, and we'll call this a tale of Guar. And always realizing that things are under construction. All right. Even if you write a contract and it's the four corners of the contract that matter, there is still a process within the contract that both parties will agree upon about changing the contract. One of the big changes, of course, is breakage. But things get amended because things change, circumstances change. Business situation is here. It's a filtration company. They make their own activated carbon. They apparently have property rights or some sort of license or pay royalties to somebody for this, another company usually. And they have two major business questions. One, what is a reasonable range? And reasonable here for us will be plausible. And we've had that discussion before. To write a contract in this case for core delivery with the potential vendor or group of vendors, maybe a syndicate of vendors. The price is considered too high and too low, need to be figured out according to something that's well beyond the model. And that well beyond is the tolerance for risk. The model cannot generate that. The model can generate, given a tolerance for risk, can generate numbers that will be consistent with tolerance for risk. But tolerance for risk is not the model. That comes from somewhere else, or perhaps corporate policy. Definitely based upon data and experience. We just visited the Coconut Community International Coconut Community site, got some interesting data. This particular HTTPS will not work, but all we have to do is go to market review. We just did that. See if I can modify this. As I said, things change. So just go to the org and search around for market review. We saw the two series. We have two countries. The direction of trade is from west to east, definitely. Again, the notion of pricing and differentials in price on the face of the earth. We want to have probably taking delivery of core closer to Indonesia than to Sri Lanka. And we'll look at the Indonesia FOB free on board price series. This is where the seller takes all of the risk until transferred to the shipper. And the INCO, International Commercial Terms of Trade for it. We will use a uniform distribution, and that is key here. This is not a different distribution than what we have seen before. We have seen the uniform distribution in day one of this course, where we assumed all of our hypotheses are equally likely. We're going to do much the same here, where our hypotheses about average prices across 12 vendors are going to be assumed to be equal. Okay, we are probably agnostic about it. We just don't know. That's what agnostic means. We do not know what is available or not available. We do have a history of maximum and minimum prices going through several booms, busts, and everything else in the commodity space, except for maybe a pandemic. Okay, interesting problem. But we do know what a high price has been, what a low price has been for different locations. The other thing is our tolerance for error. What if we choose the wrong price? Okay, that's the error. What if we choose a price of, $300 for Indonesian, and everybody's laughing at us basically in the business. We will take those sticks and stones, but they're going like, yeah, you should only have paid 280, you got suckered into it. Suckered, in businesses like this, everybody will withhold the information. People will take advantage of each other. So we need to be wary of that, and thus the need for analysis. In the end, we want to be wrong only 5% of the time. Now, this means with the same thing that happened with revenue and sales forecast. We're going to find that when we take 10,000 means and look at the distribution of means, they will begin to center, just like they did on day one when we took the uniform distribution and added data. It became quadratic. And then we added more data. and the quadratic started to pinch in, started to concentrate around the center, squeezing information literally like a tube of paste out from the tails into that concentration in the middle. Became the bell curve. And we'd had Air Dr. Professor Gauss and Marquis de Laplace. You know, there we go. We're using those distribution. At the center, 47.5 below, 47.5 above gives us two tails. And those two tails are the ones of interest to us. What do those tails look like? Let's just put them out here. Here's our distribution. Here's our mean. And if we go in this direction, 47.5%, and go in this direction, 47.5%. What do those add up to? They add up to grand total of 95%. Now there will be 5% in each tail. Oh no, there won't be 5% in each tail. There'll be 5% in both tails. How's that? Okay, so we've gone out that far. There's therefore 2.5% down here. And where's the other? 2.5% up here. You add it all up together, you get the 100%. The all in. But we're willing to go down that far to say, well, yeah, we could be wrong, or we could endure that level. Now, if we wanted things tighter, which we might, we could land it here and here. Okay, if we did that, we could have, for example, 5% down here and 5% up here and 90% in the middle, make it even tighter. Okay, a tighter range of where a low price and a high price exist. And that's the way to talk about it. Talk about it in terms of the kind of data and the kind of problem we're trying to solve. Okay. Well, having said all of that, we will simulate 12 vendor price responses many times. We will generate a distribution of mean prices across the 12 vendors. And in the reading that accompanies this, we can recall Mike Draghi's wasting simulation, which is the same as George Gilder's wasting transistors. What is the level of credibility regarding the range? Beautiful. What statistically constitutes a low price or a high price? And what's our concern with these? And if we were to model the difference between Indonesia and Sri Lanka, well, that's another interesting problem that we could take up. The bottom line is going to look like this. We're going to have, pull me out of the picture there. The bottom line is going to look like this. We're going to be able to get in future parts, we will build those goalpost riverbanks, as one boss of mine called them. We're also going to write things in English because that's the language of our particular business, in words that the client might understand. Oh, that's nice. That resets itself. that's Sri Lanka, in words that they will understand. But we will continue to use system words that the robot in the back understands. Okay, that we're programming. Here's the fence. Okay, that's what we know how to do so far. And we will be adding in a third part of this lecture. We will be adding some of the other ways of looking at intervals. Here's a Tukey way from, a standard deviation of 8 to 56. Now that's a fairly of 25 to 56 rather, only 8 in the middle. There's only a range of 8 here, and that's kind of kurtotic. But the kurtosis, notice, is only 3 with these averages, which means it's mesokurtotic, which means it acts like the thickness of tails associated with the normal distribution. Very little skew, which is evidenced in the mean of standard deviation is very close to the median. Symmetric distribution, fascinating in and of itself. The standard deviation of the deviation isn't very big. There it is. And that's where we're going with it. We will use data like this. Oh, don't look at any of that. That's in future. Here's the data, and here are the system names. So if we look at this data, you see it's been given the named range of Indo-Min, and there's Indo-Max. And all of this came from very simple eyeballing or eyeball econometrics of looking at the 2 price series for QUAR, FOB Indonesia, FOB Sri Lanka. And here's that basis we talked about. You can create a basis point by point and take averages, or in this case, take the difference between the min and the min and the max and the max. Now, that's the largest basis you're going to get. Theoretically, you could take the Sri Lankan min and the Indo-Max as a basis. That might be the case. But we are assuming no interference or entanglement like that. We're going to be assuming that all of these numbers are independently and identically distributed. And here is the distribution over here. This is a distribution from a minimum of 240 and 400 for Indonesia. And each of these is equally likely. Equally likely means 1 over, there's $160 difference there. There's 62.5 basis points. Very, very simple. And we're going to simulate from this using RAND between. Okay, that's the formula text version. Here's the actual text. RAND between Indo-Min and Indo-Max. So we do these and copy them down. And look, it's 12. Now 12, that's the number of vendors. We could have had 5, but it's important to realize that the sample size, even though we do this phone call, I'll call it a phone call, 10,000 times with each vendor, we're only sampling 12 vendors. That's it. And what are we calculating? Here's the counting model. We're doing the sample, and from the sample, we are looking only at the mean and the standard deviation. What did we learn from the sales and revenue forecast? In lecture 9, what did we learn? We learned that the most plausible mean is the same as the arithmetic mean. That's what we learned. And that was because everything again was sampled and concentrated around that central tendency of the arithmetic mean. The mean and the median were the same in both. Plausibility, the most plausible answer, if we believe in such things, is the arithmetic mean. And we're using that fact here. The arithmetic mean of standard deviations are a mean. Gives you much the same idea. Now, this is interesting. Reward to risk would be a financial way of looking at this. It's interesting to see which one. Okay, $7 of value for each dollar of risk. So that's the price of risk, if you will. We do this for in Sri Lanka. We see there is $4 of price for every dollar of risk, much less risky. Okay, very interesting, and that's simply due to the width of the two. The width of prices, which gives you an idea of how risky the prices can be very high, very low, or not so very high and not so very low. Looks like Sri Lanka is a little bit calmer for some reason or other than Indonesia. And those vendors will know those reasons. Now, the correlation is going to be very interesting since these are independently and identically distributed from a uniform distribution. Write down on a piece of paper right now what you think the mean correlation ought to be. Okay, what is your hypothesis about that? And we'll come back to that in the next part and the part after that. Well, what we do here is we take all of this and we label all of this calculation. Let's see if I can find it here. Here it is. This whole range is called calculation, this array. And what we're telling the robot to do is do this 10,000 times, recalculate this 10,000 times. That's all we're doing with a VBA program in the background. Okay, so we tell the robot to do that. And every time it does it, it uses an interface over here to communicate with the simulation report. That's the interface. You see it coming up here. So it's just copying this over. So we calculate this, copy it here, and then once we have it here, deposit it here. This is ground zero for the simulation. So at 1, at 0, at 1, copy it at run 1. At 2, copy it, run 2, and so on. Okay, so keep copying and do so 10,000 times. Okay, so cool machine. Okay, very simple. And then we do an EDA. Now, the interesting thing here is, and we'll discuss how we get this. This is the system name for standard deviation of Sri Lankan simulated prices. Notice we're going to use index, we're going to use a variables range, and refer what the user says and asks for, which is inquire results into, with a description range. Well, we'll do that next time around. But notice the EDA that we come up with. All of this is copied over here to this. As you can see, it's equal to EDA. So this is the presentation layer. Okay, this is the layer that we prepare for presentation and then present. Then we have this. Wow. If we look at setups, we see the setups here. You can see what's here, as well as putting in a source. That's another thing that we will also do. create a source. In fact, there were a couple of sources. Let me just pop these here right now. If it's FOB, it's the ICC survey. And how do I know that? If I go to market statistics and look at the weekly price update, okay. If it's anything Indonesia, you have the Indonesian coconut stakeholder, and that will be reported, whoever that is, and that might be interesting to look up, that will be reported. You can come up here. There we go. So if it's Indonesian, we're going to use that and that. Indonesian coconut stakeholder. If it's Sri Lankan, that's a different crew. It's good to locate the sources, at least begin to put these sources down. You can also put a source URL or address or their actual physical address. That would be interesting to use. And if we're in Sri Lanka, it's the Coconut Development Authority of Sri Lanka. Philippines has a different crew, which we could also begin to look at. See, what all we're doing is we're just doing a very small part of the supply chain. Now, if you build out the supply chain, which is what the procurement folks really should be doing, get an idea of how different components of the supply chain do or do not affect other components. That's a pretty important understanding for procurement, because they have to go out there and talk to those components, at least to get comparison, a window on the world at least. So be a procurement officer. Pop this in here. And the source for the correlation, of course, is this analysis. There we go. And there we go. Now, these last two pieces here are just looking at the 12 vendors, the most recent 12 vendor shot at things, at the full 10,000 runs. Okay, we're building a tolerance up here that we will hit the silk on in part 3 of this series. So those are the setups. This is where we're going to go. We're almost there. We still have some more development to do. We will do that development in parts 2 and parts 3. Our job, again, is to answer these questions. Why? Because we're writing a contract. I'll leave you with that, and happy to see you on the next round, part 2 coming up. Thanks.